Let's just have a simple practical example, which is tossing a coin. When you toss a coin, what happens? You get head or tail. What is the probability of head? Half. What's the probability of tail? Also half, right? Okay, so we call this the probability of head, and we call this the probability of tail. Suppose you want to toss the coin one more time. So if you got head the first time, the second time can still be head or tail. What is the probability you get head on the second time? Half. But this half actually is the probability of getting head given h, exactly. Given h, because that's a head on the second toss, given the first is also head. It is possible that you get head given the first is tail, but in this case the probability is also half. It didn't change, right? So that would be the probability of head given tail. Same thing here. This would be half, which is tail given head, and this will be tail given tail. Yeah, that's the probability of tail given tail. So at least now you know the names, and the probability everywhere is going to be half in this example. Now if you ask me what is the probability that all are heads, you toss the coin only twice. Suppose toss the coin twice. Toss coin twice. What is the probability that all of them are heads? Which means head. That means the probability of head. In this case, this outcome here, which is head, is half multiplied by half. So this would be half times half, which is 1/4 or 0.25. Okay? So that's a simple example of using the multiplication rule. You have a sequence, which is tossing a coin, getting a head. Another event, you're tossing a coin and getting a head. What is the chance you got head on both of them? Is simply the multiplication of the first event probability and the second event probability. Yes? No. What? Add what? How many heads you? Oh, you talk about the outcomes, like I have head here and head tail after that, and then tail head and tail. Is that what you're talking about? And you're saying all of them are equal, and that's why, because all of them are equal and the sum is 1, so each one is 1/4. Yeah, in this case, yes, because you have equal probability everywhere. Like head and tail is always half-half, but in some other examples may not be like that. So yes, you are right. You can make use of being everything equal, but not every example will be like that. So in general, if you want outcome probability, when you use the multiplication rule, just multiply it like that as a sequence of events. Okay.